Chapter 27, Suspension Systems, Day 1, Video 4, Leaf Spring Suspensions. So in the illustration here, we've got a front suspension. I can tell that by the shape of the axle beam here. We've got a steer suspension here, steer axle. A constant rate spring because we've got an eyelet on this end mounted to that bracket, and then an eyelet on this end. Again, that effective length is always going to be the center of this pin here from the bracket on the upper end of my spring shackle to the center of this leaf spring here. So this is maybe a little bit better illustration to show that as that spring lengthens and shortens, this spring shackle will pivot to accommodate that length. Here we've got some spring clips on each end so that if we have a problem where the center bolt breaks and the spring pack loses its tension, as these leaf springs may start to shift, we've got a spring clip on each end here to keep those springs from moving inside the spring pack and maybe moving out, and so it interfere with the tire and cut down a tire, or move the other way and interfere with some brake line hoses or cooling system hoses or something like that. So we'll put a spring clip in there. The U-bolt is actually shaped like a U with a bolt, a nut on each end that clamps that spring pack to the axle. Again, the spring shackle, shock absorbers here attached onto the axle, between the axle and the frame. Just a quick note on the shock absorbers. What they do is to slow down or resist the movement of the suspension. So inside of the spring we've got a piston and a rod and either a gas or a hydraulic oil that is transferred from one side of that piston to the other as that suspension collapses and lengthens out. So what it does is that oil has to pass through controlled orifices on that piston, and that causes it to resist the movement of the shock absorber. So that oil being forced back and forth through that piston, those restrictions in the piston, slows down the movement of that shock absorber, which then slows down the movement between the frame and the axle, restricts the motion of that axle and slows it down, and causes the tires to stay in contact with the surface and reduce any sort of impacts that have happened to the that are transferred from the suspension into the frame. So a rear axle suspension with a leaf spring. A couple notes here. This is a variable rate spring. I don't see any eyelets on either end. And then we've got what's called a torque rod. So before we talked about a torque leaf that helped locate that axle to the frame through this bracket. So we had a torque leaf, or we can have a separate torque rod that does the same thing. So it's attached to this bracket, attached to the other bracket here that's mounted, and our U-bolts go around it to secure it to the axle. So either way is fine. So if I know that I've got a torque rod or a torque leaf, I'm going to be dealing with a variable rate spring. Pad the U-bolts here that secure all that to the axle. So rear suspension with a variable rate spring pack. So here we've got another rear suspension system. This is going to be for a tandem drive axle, so an axle coming through here, the front drive axle, and the one coming through the back here, the rear drive axle. All leaf springs that are supporting that weight. Variable rate springs. I don't see an eyelet on the end of any of these leaf springs. And then torque rods here indicating that those springs are free to move within the brackets, and then locating the axles so they don't move. The U-bolts. So we've got the cam brackets on each corner here, but now in the center between those two leaf springs, we've got what's called an equalizer beam. So we've got a mount here that's got a center pivot and a short beam that connects this front leaf spring to the rear leaf spring, right? So that what ends up happening as the suspension compresses and expands, it's going to share the load on this side of the tractor between this leaf spring, go through the equalizer spring to the other side, right? To the rear leaf spring. So we've got two short leaf springs that are combined together to make an effective one large leaf spring, sharing the load between the two. Same thing happens on the other side. So we're sharing the load side to side. A short equalizer beam that helps or initiates that sharing of the load between the front and the rear drive axle leaf springs. A relatively short equalizer beam, so that would mean very little articulation between the two axles. So this would be used in a long haul or a terminal-to-terminal truck where it's not seeing uneven surfaces very often. It's mostly freeway driving, that sort of a situation, in and out of a yard, paved, improved surfaces. So not much movement of the suspension. So again, this would be characteristic of a long haul truck. Example we've got in this illustration is a equalizer beam, quite a bit longer equalizer beam on here as opposed to the equalizer beam on our long haul truck. Again, a leaf spring suspension, spring clips, U-bolts of a different shape but still have the same function. The front bracket, the rear bracket, no eyelets, so this is a variable rate spring. And now we've got this large housing here with the equalizer beam that's approximately 6 foot long that goes underneath the suspension and underneath the drive axle. So the drive axle would come through across the top of those equalizer beams and between that and the brackets here. So a front drive and then a rear drive. We've got located up here some torsion rods that are going to keep the suspension from or keep the axles located. So this would be located on a bracket that's on top of the rear axle housing. Same on this side here, keeps it located. The characteristic of this one is as that suspension moves up and down, we get a lot of movement relative between these two axles. So we're sharing the load between the two by the one common leaf spring and then the center pivot here of my equalizer beam, but lots of movement up and down of this axle beam, equalizer beam. So this would be more of a heavy haul, off-road, on-off-road type of a situation, maybe a rock truck coming in and out of a rock quarry and then traveling on the highway where we'd need some load carrying capacity and then the articulation that we needed to go over that rough terrain.